Continue on physical chemistry. We're in chapter 18, section 9 now. Now we're going to talk about a particle in a 3D box. So here's the box here. We're going to have x, y, and z. So it's going to have in x from 0 to a, in y from 0 to b, and then in z from 0 to c. So just to make it less confusing, we're going to say that a is not equal to b, b is not equal to c, and a is not equal to c. So the three sides are different lengths, just so we can keep track of which is which. There's another reason for that we'll talk about later. So again, we're saying that V, potential energy, is equal to 0 inside the box, and then V, potential energy, is equal to infinity outside the box. That's supposed to be capital V for potential energy, remember. So we're going to say the x position is greater than or equal to 0 and less than or equal to A. The z position is less than or equal to, or greater than or equal to 0 and less than or equal to c. And the y position is greater than or equal to 0 and less than or equal to b. So here's the time-independent Schrodinger's equation. So we get minus h bar squared over 2m times this entire quantity. The second derivative of psi with respect to x, plus the second derivative of psi with respect to y, plus the second derivative of psi with respect to z. And that's going to be equal to energy times psi. So remember, E is the total energy, which is, in this case, is going to be equal to the kinetic energy because the potential energy is equal to 0. So we have psi is equal to this capital X function of x, capital Y function of y, this capital Z function of z. So we have three separate functions. So we're going to have x of x is equal to the square root of 2 over a times sine of n in x times pi times x over a. And then, so energy in the x is going to be equal to n of x squared times h squared over 8ma squared. And then for y, it'll be the same thing. It'll be the square root of 2 over b times sine of n for y times pi times y over b. So the energy of y is going to be equal to n for y squared times h squared over 8mb squared. And then the same thing for z. The function for z is going to be equal to the square root of 2 over c times sine of n of z times pi times z over c. So the energy levels for z will be n for z squared over h squared over 8mc squared. Now we have psi is equal to the square root of 8 over abc times sine of n of x pi x over a times sine of ny pi y over b times sine nz pi z over c. And then the energy level, of course, energy is just a scalar, it'll add right up. Total energy is going to be the energy in x plus the energy in y plus the energy in z. So now we have energy is equal to h squared over 8m. It's going to be this whole quantity, n of x squared over a squared plus n of y squared over b squared plus n of z squared over c squared. So remember, the ground state will be when n of for x is equal to 1, n for y is equal to 1, and n for z is equal to 1. Now we're assuming that x, y, and z can be separated into three separate functions. That's all for section 9.